All right, we are live. Good morning, everybody. And I'm coming in today with a very exciting episode on immutability constraints for dynamic tables. Well, to talk all about it, I have with me Daniel, senior software engineer who's working on the cool feature, and he's here to talk about all things immutability constraints and generally about dynamic tables as well. Welcome, Daniel, to the show.
Thanks, Vino. Super happy to be here.
Yeah, we are very excited to hear from you. But firstly, let's start with the fundamentals. For some of us who may be using Snowflake but are not familiar with dynamic tables, what exactly is a dynamic table?
Yeah, so dynamic tables are Snowflake's way of making declarative data pipelines. So basically, the idea with dynamic tables is you say what data you want. You describe the output, whether it's a join between two tables, aggregates, window functions, whatever features you want. You just describe the shape of the data, and Snowflake makes it happen for you. Dynamic tables can be chained together into larger pipelines. And then, yeah, Snowflake handles incremental refresh and all of the scheduling and orchestration and execution for you, so you don't have to worry about that yourself. So our goal is really to making data pipelines really simple and easy and performant all at the same time.
Gotcha. That sounds very cool. So you're telling me I don't have to handle the infrastructure, orchestration, none of that. I just define the state, like the output state for what I want from the data.
Exactly, yeah. So you define the output state, and then additionally, the two other important parameters for dynamic tables are target lag and warehouse. So target lag is how you specify your freshness requirements. So if you want your data to be within 1 minute of real time, you say target lag equals 1 minute. If you're running something with much like sort of lower requirements, maybe you only need it fresh within a day. You can say target lag equals 1 day. So we support the entire spectrum of latency requirements there, from like batch use cases all the way down to 1 minute. And then the refreshes themselves run on warehouses, just like normal Snowflake queries. So you still get all of the standard control over spend, isolation, everything that you're used to in Snowflake.
Gotcha. I think that sounds very cool because I've been a data engineer in my past life and I've only worked with the batch workloads and I've always been scared to touch the streaming side of the world because I'm like, I don't want to have to write Java and like deal with, Java SDK and whatnot. But now you're telling me I could use dynamic tables to write, maybe I want to say near real-time data pipelines. Is that fair?
Yeah, we're not in the real-time space with dynamic tables, but definitely near real-time. Yeah.
Gotcha. That's very cool. But why are we talking about dynamic tables today? Because I know Snowflake has introduced dynamic tables like a couple of years ago. So what's new today?
Yeah, so the big thing that I want to talk about today is a new feature called Immutability Constraints. So dynamic tables prior have what we call delayed view semantics. So the contents of your dynamic tables act as if your dynamic table was a view, potentially with that lag, as we discussed before. And that's a really powerful, simple paradigm, right? You just say, here's what my data should look like, make it work. But there are use cases where that just doesn't quite fit. So one of the really big ones is there's a lot of cases where you want to have your staging data coming in, you want to process that with your dynamic table, but you want to be able to delete that staging data when you're done with it, right? Without immutability, when you do those deletes in your staging data, those deletes propagate into your dynamic table as well. Other use cases that come up are sometimes you don't want to go back and reprocess old records. Say that you're doing a fact dimension join. You've got your facts constantly streaming in, and you're occasionally updating your dimension table as well. Maybe when you update a dimension row, you don't want to go back and reprocess all the old facts that join with that dimension, because that's expensive and you don't necessarily care about that change to the old data. So how do you address that? So what we're doing is we're introducing this new option on dynamic tables called immutable where you specify a predicate that says this portion of my dynamic table is immutable. It's frozen, it's locked, those rows can't be touched, no new rows can be inserted into that region. So generally we think of this as being used with sort of time-based predicates of saying something like all data older than 7 days or all data older than a day in my table should be immutable. And then deletes in that region don't propagate. We don't need to recompute old join results in that region. We don't need to reaggregate any data in that old region, etc. So it keeps it locked down, makes your refreshes more efficient, and yeah, ignores those changes that you don't want.
Gotcha. I think this is very cool because if I have to think about the life of a data engineer without this feature, if I'm using dynamic tables today, my expectation is that my dynamic table keeps updating as my source keeps getting updated. And that's sort of like the intentional behavior, because as the new data keeps coming in, you want your dynamic table to get updated. And even if that change means deleting your data upstream, you want that deletion to be propagated. But there are some times where we intentionally want to delete, like for saving data, for example, but we don't want that to be propagated downstream. So I guess this is sort of, well, it's easy and simple to create a dynamic table, but also if you need some sort of flexibility or more control around it, this immutability comes in right there. That's very
Exactly. So we're giving you this one extra step of control. So it's not like a full sort of imperative world where you're just doing your own DML and doing, like the system is still able to reason and understand about what you're doing. So Snowflake can still apply all of the magic of dynamic tables, but you have that extra level of control so that you're only getting changes where you want those changes.
Gotcha. Yeah, I think I would totally take having to write one extra clause instead of having to write a whole new data pipeline. So I am not too bothered by this one extra control or flexibility that I have. Very exciting. And I was just thinking as we were talking about it, a little birdie tells me you have a full demo that you wanted to show us on how to use them.
Yeah, let me pull that up real quick. Okay. So for this demo, we've got, let's say that we're doing, this is sort of a simple join and aggregation use case. So we've got one of our input tables is transactions. So we've got a customer ID, a timestamp on those transactions, and a value, right? So that, and then we also have a table containing some metadata about our customers. So here, for this simple example, we have our customer IDs and we've got some location for where those customers are. And let's populate that with some test data just so that we have something to work with. And then the dynamic table that we're going to use here is computing some statistics about those locations. So here we want to, we're grouping by location and hour, computing the hour from those timestamps. And we're joining the transactions table with the customer table to get all of that together. So that's the setup that we're in. But we want to be able to, in this case, these transactions, we don't need to keep these around forever. We just want them to flow through the system. So here, we want to be able to delete the old ones. So we're setting this immutable where hour is less than current timestamp minus a day. So all of our aggregates that are older than a day are locked. We are not going to touch them. And so now we can automatically delete all of the old transactions with a task here. So we're creating a task. We're running it every 12 hours. And the body of the task is just a simple delete statement where we're deleting everything older than a week. So we're only keeping this sliding window of transaction data and deleting the old ones. And our DT will still contain all of that old historical data. So we can, if we pop over here, we can look at our dynamic table, take a look at its data, and we've got lots of old rows still in the DT, even though we have that task clearing out old data.
Gotcha. I think this is very cool.
Yeah.
Before we proceed further, I have a quick question.
Mm-hmm.
I know in this example, we use this immutable where clause as part of creating a dynamic table. But tell me, what if I created a table and said, well, I want to not touch any data that is older than 1 day. But now suddenly, because of whatever changes that I have to deal with, I want dynamic table to update some historical data also. How would I do that?
Yeah. So this immutable where property is alterable. So in this case, say that we realized later that, oh, actually, we have some data from a few days ago that we really need to reprocess and incorporate in. So we can just do that on the fly with alter dynamic. So we can alter our table, and then we can update that immutable where predicate to something else. So if we want to say, okay, we actually need to process a week of data, we can just do that. Bump it back to 7 days. That will cause that the data between 1 day old and 7 day old to get reprocessed on the next refresh. And then we'll keep moving forward with regular incremental refreshes. And this goes the other way too, that if we've done that backfill, that week old backfill, and we want to bring the immutability back to 1 day, we can do that too. We can just bump that back up to a 1 day, immutable where, and that will move that forward again. And for cases like this, when we are making the immutable region larger, that happens with zero extra compute. That's a pure metadata operation. When you shrink the immutable region, we recompute the newly mutable data to make sure that we've picked up whatever sort of backfill you wanted to do. And obviously, you can call this set on a dynamic table that has no immutability, so you can apply it from the first time with zero compute.
Mm-hmm. Gotcha. Love that flexibility. I'll let you keep going.
Yeah. So one of the really cool things that immutability also unlocks is there are a lot of use cases where you have an existing pipeline that's running that's not dynamic tables, and you want to convert that to dynamic tables. Without immutability, your only option is to create a brand new dynamic table. It will go and recompute everything. It does a full backfill when you compute the dynamic table, and sometimes that's what you want, but sometimes that's really expensive and you don't want to deal with that. And so immutability also comes with the ability to backfill a dynamic table from an existing table. So here, say that we already have a bunch of historical aggregates that we want to initialize our pipeline with. So they're all in this historical statistics table. So instead of wanting to compute from just the input tables, we want to pull those aggregates from this historical table. So we have this new backfill option that you can specify when creating a dynamic table. So here we can do that backfill. And now all of the data in the immutable region of this dynamic table is going to come from historical statistics instead of coming from the definition. Everything in the mutable region comes from the definition like normal. Incremental refresh will just work as normal, and you have your dynamic table.
Gotcha. I think this is even more powerful, like using backfill from in conjunction with immutable where. So you could have like almost like two sets or like two sources to your dynamic table, which is very cool.
Yeah, it gives you a lot more operational flexibility, right? It means that your dynamic table now is not, it doesn't just act like a view, right? It has its own data now, which can be a very, very powerful extension to the dynamic tables framework. Speaking of places where this adds a lot of extra power, it gives us the option to update a dynamic table definition without having to recompute everything. So let's say that today we have these sums. Let's say we want to compute averages too, right? Without immutability, you would have to just create or replace the dynamic table, create a brand new one that also computes average, and it would go back and recompute over all of your historical data. Or if you had been deleting your input data, it just wouldn't be able to do a backfill beyond your retention horizon. But now what we can do is we can clone the dynamic table into a regular table. That's also a new feature we've recently added. So if you want to like take a snapshot of your dynamic table as just a regular table, you can do that now. Here we can add that new column that we want. So this is going to, for now, it's just backfilled with nulls in this clone table. And now we can create or replace our dynamic table, backfilling from this clone of the dynamic table with a definition that now includes this new average computation as well. So we can pull this up. And I probably put a little bit too much data in this. It's got about 1 billion rows here, so it takes a couple seconds to run. And so now we have our dynamic table. And what we can see is if we look at sort of the range of rows that have this average, everything in the past day has this average column, and all of the older data has nulls here. So you can control the amount of backfill that you want on this new column with the immutable region.
Gotcha.
So, yeah.
I think this is very cool, but I'm also thinking in terms of how would I decide what portions of my dynamic table do I not want to change? Like this whole immutability process. Is it? I know the answer probably is it depends, but I'm looking for like more guidance if there is any on that.
Yeah, I mean, honestly, it does ultimately come down to business requirements in most cases, right? Like you're going to have some sorts of requirements that like you're building dynamic tables, you have this data product, right? And your customers have requirements on what they want that data to look like. And they may care about changes going back a day, they may care about changes going back a week, a month, whatever. And that's ultimately generally the way to determine this immutability. For cases where you really don't have old changes and you're using this just for performance, then basically making sure that your immutability is sort of reasonably large. You want a mutable region that's long enough that you have space for your refreshes to run and operate in that mutable region is basically the guidance. So you don't want to make it really, really narrow. That's a use case that we are actively working on. We're working on different ways of expressing immutability that let you express immutability in ways that are sort of dynamic in terms of any sort of delays that happen to processing your pipeline. So stay tuned for stuff in that space. There's some cool stuff we're working on.
Gotcha. Okay. And I think with that, I also want to tell the audience and the folks who are watching, if you have any questions about dynamic tables, using immutability constraints, or anything else, or any other feature around dynamic tables, please put it in the comments, and I will have Daniel answer that for you guys. And with that, I have is it fair to say, whatever, depending on my use case, industry, and all of that, whatever I think is historic data, it's fair to label them as immutable. Like for fraud prevention in real time, maybe 2 days old data is historic, but for somebody, a week old data is historic, right? So
exactly, yeah. So it's data that you still want to be able to query, but you don't want to change anymore. So it doesn't need to be updated. You don't want to pay the cost of changing anything about that data, but you still want it to be there in the table and queryable.
Gotcha. I think that's cool. And it's possible that we know all these features, but I also want to know, if I'm not using immutable where, how am I dealing with this today?
So there's a lot of customers that we've talked to who just aren't using dynamic tables because of the lack of these features. That because they weren't able to lock this down, instead of using a dynamic table, they're using streams and tasks, writing a big complex merge statement themselves so that they can make sure to only touch the data that they care about. And so this new functionality lets you avoid having to write all of that complex code yourself. It lets you express it in this much simpler way. Some customers are just like when they need to update their dynamic table definitions, they're just paying the cost of recomputing everything, and they don't want to pay that cost. So now they have this flexibility. They don't have to do that.
Gotcha. I think that's helpful to know. Also, I could see how this could be a blocker for some of the folks who even explore dynamic tables. For folks looking for flexibility, this probably changes it for them. What else is coming in dynamic tables?
Yeah, so other stuff that we've been working on recently. So performance is always an area that we are working on a lot. Some of the really big recent ones, we've made significant improvements to dynamic tables that have like multiple group bys and joins in them. Those perform now significantly better than they used to incrementally. We've also recently significantly improved SCD1 type use cases, which is where you're like picking the latest row per key. It's a very common sort of CDC type use case that we see. We made that perform significantly better. So if you have those CDC use cases that you aren't using dynamic tables for, I would say, yeah, it's a good time to try that out again. And finally, we also just added the ability to use AI functions in incremental dynamic tables. So if you want to do like AI complete type stuff or any of the other cool built-in AI functionality that Snowflake has, you can do that directly in a dynamic table. It will run incrementally now, so you're only calling those functions on new rows as they show up in your inputs. That unlocks a whole bunch of new use cases as well in dynamic tables.
Mm-hmm. Yeah, I think that's very cool. Firstly, like bringing in AI to your pipelines is, I think, super powerful. And also this whole incremental refreshes really saves costs, because like when you're thinking about running Gen AI functions, you want to be very mindful of the whole cost involved. And then this really like sort of seems like a good combination with AI SQL and dynamic tables together. And there's just one thing that you talked about earlier. I probably want to like ask this before we wrap it up. Essentially migrating an existing data pipeline to dynamic tables, but without recomputing rows. Can you like maybe talk about that a bit?
Yeah. So it uses that backfill operation, right? So like for whatever stages in your pipeline you have, like each table can be migrated to a dynamic table, sort of more or less one-to-one, or you can potentially drop some of them if you don't need them. And you can use the backfill operation to copy that data over from your existing pipeline into your dynamic tables without having to do that recomputation, right? So it lets you...
Gotcha. Sorry, I was going to say, so backfill from that existing table that you already have, a table or view, right?
Yeah, it needs to be a table. So one really cool thing about backfill that I didn't mention is that it uses the same mechanism that clone does internally. So it doesn't have to actually copy the data. It's a metadata only shallow copy of the data that then does like copy on write. So like they are logically independent, but we don't have to actually physically copy any files. So it's really fast.
Gotcha. Okay, that's powerful. So if I have an existing data pipeline, I take the output of that, which is a table, and then when I create a new dynamic table, I essentially say backfill from this table. So you take all the historic data that the table currently has until up to maybe today. And then when I want to really convert it into a dynamic table, I will have some logic of what I want the dynamic table to be. So from this point onwards, I would use that select clause to really define what I want the dynamic table to be. So you
Exactly.
have this beautiful combination of the table from the past, but also like eventually it's all part of that one dynamic table. I think this is very powerful, especially for folks that we were just talking, right? If I have not been using dynamic tables, like how do I get started? It is not too much a lift. This is definitely interesting. And folks who are watching who have not tried out dynamic tables, this is your chance. And I will also probably share a link to the blog that Daniel wrote in the comments as well. So you can go explore several other use cases for when you want to use this immutable where clause and generally dynamic tables as well. All right. I guess, Daniel, with that said, we are at the end of the episode. Thank you so much for talking to us all about, firstly, what is the dynamic table and what is the declarative pipelines and why is that paradigm important, and how, like even as a batch data engineer, how I could use dynamic tables to get almost closer to, writing near real-time streaming pipelines for my use cases. Again, it really depends, but you can go as close to up to 1 minute of, 1 minute of target lag, which is very cool. And how, if you're already using dynamic tables, you could check out this immutable where clause to essentially get more flexibility and control to the existing table that you have. And, oh, wow. Okay. Right when we are going to wrap up, there's just one more question from Sunil. Maybe we want to take that. Do dynamic tables also use micro partitions and time travel like permanent tables?
Yeah, they do. So, like under the hood, dynamic tables are structured just like a regular table in Snowflake. So the actual storage is exactly the same as normal Snowflake tables. We support both like Snowflake native storage as well as Iceberg. And then the dynamic table refreshes that keep the dynamic tables up to date are essentially DMLs. I mean, they're like, we do all of the incrementalization work for you. So we're building up these sort of very complex merge plans internally. But at the end of the day, it is just the DML. It's reading and writing micropartitions like normal DMLs. And so querying a dynamic table is exactly the same as querying a normal table at Snowflake.
Gotcha. Okay, I think that's helpful. And with that said, we are at the end of the show. And thanks again, Daniel, for helping us with everything that we need to know. And we cannot wait to get started.
Oh, we've got one more question that just came in too. Should we cover that or?
Okay, folks, let's take 5 more minutes for questions because I don't want to do another wrap up and then get another question. Yeah. So throw all your questions in the comment sections and we have 5 more minutes before we wrap up, okay? With this question is from Nicholas. Let's say you have SCD type 1 that we import from an ERP, but how could you produce a SCD type 2 version leveraging dynamic tables?
Yeah, so you can express all of the SCD variants in dynamic tables essentially using window functions. So an SCD type 1 looks like qualify row number equals 1 over partition by your partitioning key, order by timestamp descending. SCD2, you usually use lead or lag to look for the next or the preceding row, depending on how you've set things up. So you can express that today in a dynamic table. So for people who aren't aware, SCD2 is where each row has sort of a validity interval saying this row is the value of this key between this start time and this end time. So you can use like the like if every input row is tagged with the start time, you can use the lead window function to find the next row to load that end time.
Gotcha. Very cool. And we have another question from Ajay, but I think this question is like exploring if this is a good use case for dynamic tables. Like their data source is from a Snowflake data share, and a staging view is created on top of the shared data, where masking policies are applied to secure sensitive information. So this masked data is then ingested into the raw layer table for downstream processing. Would it be feasible to use a dynamic table in the raw layer instead of a regular table? Which is
absolutely. So we definitely see this use case come up. So the way that dynamic tables handle masking policies is they respect them, basically, right? So the dynamic table is running as a particular role. It's the role that owns the dynamic table. So if the masking policy says this role is only able to see these rows, those are the only ones that the dynamic table will see from the input. So you get exactly what you want. So yeah, creating a dynamic table here will respect the masking policy, do your ingest, it'll do exactly what you want in this case.
Gotcha. Awesome. Well, that said, folks, 2 more minutes. Let's get the questions rolling. And while the questions are coming in, Daniel, I was just thinking about it. I know usually we have product folks coming in and talking about the features. So there's more of, oh, why did we build this? But you're also the person who built it. So how was the experience building it? Is there anything that you could talk about from that?
Yeah, I mean, so it's definitely fun to work in this space, right? Because we're in this space where we're trying to make stuff just work out of the box, right? Like it needs to have a simple declarative UX, but then we like underneath, we still need to actually figure out exactly like what operations need to be run. How do we make that efficient? How do we make sure that everything is really tightly integrated into the rest of Snowflake? Like we really want to make sure that everything here works really well together. We don't want it, like we're not building something off on an island. Like dynamic tables are really a core part of Snowflake and are deeply tied into the standard Snowflake compiler, et cetera. So that was like both, it was interesting to sort of learn about new parts of the compiler that I hadn't seen before, making sure that like everything would work and perform well, that we like when you specify that immutable region, we really want to make sure that we're never actually looking at that data. We don't want to be paying that cost. So the sort of getting the performance working right was a very interesting problem.
Gotcha. And also, are you telling me that every time I create a dynamic table, you're not going and running DML operations for me?
Not personally, no. That would be a bit much.
Oh my gosh. But yeah, okay then. This time, I think I'm probably going 3, going 2. Folks, this is your last chance. All right. Firstly, I think I really want to thank the audience for coming in with like very specific and deep questions. Truly appreciate that. Secondly, Daniel, thanks again for coming in, helping us with all things dynamic tables and really the immutable where clause and where to use it. Truly appreciate it. And we can't wait to have you again on the show.
Yeah, thank you, Vino. It was great talking with you today.
Yeah. Thanks.